What if I told you there's an entire world thriving beneath the Earth's ice, a place so extreme it makes the Sahara Desert look like a beach vacation? Prepare to have your mind blown as we dive into ecosystems you never knew existed, filled with creatures that redefine the very meaning of survival. Forget aliens in space. The most mind-bending life forms are right here on Earth, hidden beneath miles of ice. This isn't just about polar bears. We're uncovering microscopic marvels and bizarre creatures that have engineered astonishing ways to survive in the harshest conditions imaginable, challenging everything we thought we knew about life for centuries. Humanity viewed the vast, frozen expanses of our planet as barren, lifeless wastes. The colossal ice sheets of Antarctica and Greenland, the sprawling glaciers clinging to mountain peaks, the seemingly endless stretches of Arctic sea ice, all were considered desolate, inhospitable realms where life simply could not take root. We imagined a world of stark white and frigid blue, a silent, static monument to Earth's most extreme temperatures. But this perception, as groundbreaking scientific discoveries have revealed, is a profound deception. Beneath the shimmering, impenetrable surface of the ice lies a vibrant, interconnected biome teeming with life that defies conventional understanding. Imagine standing on the desolate, wind-swept plains of the Antarctic Plateau, an endless expanse of white stretching to the horizon. The air bites with a cold that sears the lungs, and the silence is absolute, broken only by the whisper of the wind. This is the image that typically comes to mind when we think of Earth's frozen frontiers, yet beneath your feet, perhaps miles below, a hidden ocean pulses with microbial activity. Ancient lakes harbor unique evolutionary lineages, and microscopic organisms cling to life within the very ice crystals themselves. This isn't a desolate wasteland. It's a thriving, dynamic world, hidden in plain sight. The journey into this unseen world begins not with a spaceship, but with a drill. Scientists, driven by an insatiable curiosity and armed with cutting-edge technology, have begun to pierce the icy veil, revealing ecosystems that are as alien and uninspiring as anything found on distant planets. From the intricate networks of brine channels within sea ice to the vast, isolated lakes buried beneath continental glaciers, these environments are proving to be biological treasure troves. They are home to extremophiles, organisms that not only tolerate but thrive in conditions that would instantly kill most other life forms. These are the true pioneers of survival, pushing the boundaries of what is possible and, in doing so, forcing us to rethink the very definition of life itself. We are about to embark on a journey into a realm more alien than outer space, a world of perpetual twilight, immense pressure, and temperatures that plunge far below freezing. Yet, within this seemingly impossible landscape, life persists, adapts, and even flourishes. This is the story of Earth's unseen ecosystems, a testament to the incredible resilience and diversity of life, and a stark reminder that even in the most extreme corners of our own planet, there are still profound mysteries waiting to be uncovered. Prepare to have your understanding of life, and indeed of Earth itself, transformed. This is the world beneath the ice. Beyond the chill, survival superpowers to comprehend life under ice, we must first abandon our conventional notions of what life requires. The rules that govern the sun-drenched, temperate ecosystems we are familiar with simply do not apply in these frozen realms. Here, survival is not merely a matter of finding food and avoiding predators. It is a constant battle against the fundamental laws of physics and chemistry. The organisms that call these environments home are not just tough. They are masters of adaptation, possessing what can only be described as survival superpowers. At the heart of this incredible resilience lies the concept of the extremophile, an organism that thrives in extreme environments under conditions that would be lethal to most other life forms. These are not monstrous creatures of science fiction, but rather microscopic marvels of evolution, each with a unique arsenal of adaptations that allow it to conquer the cold. One of the most formidable challenges they face is the formation of ice crystals within their cells. As water freezes, it expands, and the sharp, crystalline structures it forms can rupture cell membranes, effectively destroying the organism from the inside out. To combat this, many extremophiles have evolved a remarkable defense mechanism: antifreeze proteins. These proteins, a testament to the ingenuity of natural selection, do not prevent water from freezing altogether. Instead, they bind to the surface of ice crystals, preventing them from growing larger and causing cellular damage. It is a delicate, molecular dance, a constant negotiation with the forces of nature. Imagine a microscopic bouncer carefully managing the crowd of ice crystals, ensuring they remain small and harmless. This is the reality for organisms like ice algae, which bloom in the intricate network of brine channels within sea ice, and for certain species of fish that navigate the frigid polar oceans. Their very existence is a testament to the power of these remarkable proteins, but antifreeze proteins are just one of the many superpowers in the extremophile arsenal. Survival in the cold also requires a fundamental rewiring of an organism's metabolism. In the sunless depths beneath glaciers and ice sheets, photosynthesis, the process that powers most life on Earth, is impossible. Here, life must find alternative sources of energy, and it does so through a process called chemosynthesis. Instead of harnessing the energy of sunlight, these organisms derive their power from chemical reactions, metabolizing minerals and gases found in the surrounding rock and water. They are, in essence, living off the very bones of the Earth. Consider the specialized bacteria that have been discovered in subglacial lakes miles beneath the Antarctic ice sheet. These organisms have never seen the sun, yet they form the base of a complex food web supporting a diverse community of other microbes. They are the primary producers in this hidden world, the foundation upon which an entire ecosystem is built. Their metabolic pathways are a marvel of biochemical engineering, capable of extracting energy from sources that would be considered inert by most other life forms. They are a living reminder that life is not limited to the familiar, sun-drenched corners of our planet. Among the most celebrated of these survival artists is the tardigrade, also known as the water bear. These microscopic invertebrates are the undisputed champions of resilience, capable of surviving not only extreme cold but also extreme heat, radiation, and even the vacuum of space. When faced with life-threatening conditions, tardigrades enter a state of suspended animation called cryptobiosis, in which their metabolic activity drops to almost zero. They retract their limbs, curl into a desiccated ball, and wait. In this state, they can endure temperatures as low as -270 degrees Celsius, just 1 degree above absolute zero. When conditions improve, they rehydrate, unfurl, and carry on as if nothing happened. They are a testament to the incredible plasticity of life, a living embodiment of the idea that what doesn't kill you makes you stronger, the unseen food web. In these sunless, freezing environments is a testament to the interconnectedness of life, even in the most extreme of circumstances. It is a world built on the foundation of chemosynthesis, where bacteria and other microbes form the base of the food chain. These primary producers are consumed by other microorganisms, which are in turn consumed by larger, more complex organisms. It is a delicate, intricate dance of life and death, a testament to the remarkable ability of life to find a way, even in the most unlikely of places. This is not a world of scarcity, but rather a world of ingenuity, where life has learned to thrive on the very edge of possibility. Hidden oases, subglacial lakes, and rivers. For decades, the idea of vast bodies of liquid water existing beneath miles of solid ice was considered a scientific fantasy. The immense pressure and frigid temperatures were thought to preclude the possibility of anything but frozen water. Yet, in the late 20th century, seismic surveys and radar mapping began to reveal tantalizing hints of something extraordinary beneath the Antarctic ice sheet. Vast, interconnected networks of subglacial lakes and rivers. These hidden oases, shielded from the surface world for millions of years, represent some of the most pristine and isolated environments on Earth, offering a unique window into ancient ecosystems and potentially the origins of life itself. The most famous of these hidden oases is Lake Vostok, a colossal freshwater lake buried beneath approximately 3,700 meters to 0.3 miles of ice in East Antarctica. Discovered in 1996, Lake Vostok is roughly the size of Lake Ontario, making it one of the largest lakes in the world. Its existence challenged prevailing scientific paradigms and ignited a fervent debate about the possibility of life thriving. In such extreme isolation, the sheer depth of the ice above it means that Lake Vostok has been cut off from the Earth's atmosphere and surface ecosystems for an estimated 15 to 25 million years, making it a living laboratory for studying evolutionary processes in extreme isolation. The exploration of Lake Vostok has been a monumental undertaking, fraught with technical challenges and ethical considerations. Scientists have employed specialized drilling techniques using hot water and sterile procedures to prevent contamination of the pristine lake environment. The goal is to penetrate the ice sheet without introducing foreign microbes, ensuring that any life discovered within the lake is truly indigenous. The first successful penetration of Lake Vostok occurred in 2012, revealing a water column that had been untouched for millennia. Subsequent analyses of ice accreted onto the drill bit and water samples have confirmed the presence of diverse microbial communities, including bacteria and archaea, some of which are genetically distinct from any known organisms on Earth. Lake Vostok is not an anomaly. Since its discovery, over 400 subglacial lakes have been identified beneath the Antarctic ice sheet, and more are being discovered regularly. These lakes are not static, isolated puddles. Evidence suggests they are part of active hydrological systems with water flowing between them through subglacial rivers. This dynamic network means that these environments, while isolated from the surface, are not entirely stagnant. The movement of water can transport nutrients and even microbes between lakes, creating a complex and interconnected subglacial biosphere. The existence of liquid water beneath glaciers is not limited to Antarctica. Recent findings have shown active hydrological systems under glaciers in Greenland and even in the Canadian Arctic. These discoveries are revolutionizing our understanding of glacial dynamics and the potential for life in these previously unexplored realms. The presence of liquid water, driven by geothermal heat and the immense pressure of the overlying ice, creates habitable zones where microbial life can flourish. Why are these oases crucial? Beyond their intrinsic scientific value as unique ecosystems, subglacial lakes and rivers hold profound significance as potential refugia for unique life forms and as crucial clues to early Earth. The isolation of these environments means that any life found within them has evolved independently for millions of years, offering insights into the fundamental processes of evolution and adaptation. They are living laboratories, providing a glimpse into how life might have originated and persisted on a young Earth before the advent of complex atmospheric conditions. Furthermore, these subglacial environments are considered excellent analogs for potential extraterrestrial life. Icy moons in our solar system, such as Europa, Jupiter, and Enceladus, Saturn, are believed to harbor vast subsurface oceans beneath their icy shells. The study of Earth's subglacial lakes provides invaluable data and methodologies for future missions aimed at exploring these distant worlds, offering a roadmap for the search for life beyond Earth. The creatures thriving in Earth's hidden oases may well be distant cousins to organisms awaiting discovery in the cosmic ocean. Ice is a time capsule and climate barometer beyond harboring hidden ecosystems. Ice itself serves as an invaluable archive, a frozen time capsule preserving secrets of Earth's past. For scientists, ice cores are like geological diaries, meticulously recording changes in climate, atmospheric composition, and even ancient biological activity over hundreds of thousands of years. By drilling deep into the ice sheets of Greenland, In Antarctica, researchers extract cylindrical samples that contain layers of compressed snow, each layer representing a year or even a season of Earth's history. Within these layers, trapped air bubbles preserve samples of ancient atmospheres, allowing scientists to reconstruct past concentrations of greenhouse gases like carbon dioxide and methane. This provides a direct, irrefutable record of how Earth's climate has changed over vast time scales, offering critical context for understanding current climate trends. The dust, volcanic ash, and even pollen grains embedded within the ice tell stories of ancient winds, volcanic eruptions, and shifts in vegetation. It's a silent, frozen narrative of our planet's dynamic past, but the ice cores hold more than just atmospheric and geological data. They also contain ancient biological secrets. Microbes and even viruses can become entombed within the ice, preserved in a state of suspended animation for millennia. When these ice samples are melted in controlled laboratory conditions, some of these ancient organisms can be revived, offering a glimpse into the microbial diversity of past eras. The discovery of 15,000-year-old viruses and bacteria in Tibetan glacier ice, for instance, has opened up entirely new fields of research, prompting questions about the long-term viability of microbial life and the potential implications of their reawakening in a warming world. The delicate balance of these icebound ecosystems is profoundly sensitive to even subtle climate shifts. The very existence of subglacial lakes, for example, relies on a precarious equilibrium between geothermal heat, pressure, and the insulating properties of the overlying ice. As global temperatures rise, glaciers and ice sheets are melting at an accelerating rate. This meltwater can alter the hydrological systems beneath the ice, potentially changing the conditions within subglacial lakes and rivers. Increased meltwater can also lead to the opening of previously isolated environments, introducing new microbes and altering the delicate balance of existing ecosystems. Furthermore, the thawing of permafrost, permanently frozen ground, in Arctic regions is releasing vast quantities of ancient organic matter and dormant microbes. This process has the potential to release significant amounts of greenhouse gases, further accelerating climate change, and could also reintroduce ancient pathogens into modern ecosystems. The urgency of understanding this world beneath the ice is therefore paramount. As climate change accelerates, threatening these unique environments, the secrets they hold about Earth's past and the resilience of life become even more critical. We are in a race against time to study and understand these fragile ecosystems before they are irrevocably altered by human-induced climate change. The ice, once a symbol of permanence, is now a stark reminder of our planet's vulnerability. The future of frozen frontier exploration of Earth's hidden icy worlds is still in its infancy, yet it promises to revolutionize our understanding of life, both on our planet and potentially beyond. The scientific community is pushing the boundaries of technology and ingenuity to delve deeper into these frozen frontiers, revealing secrets that were once thought to be forever out of reach. One of the most exciting new research frontiers involves the development of advanced robotic submarines. These autonomous underwater vehicles, AUVs, are designed to navigate the dark, high-pressure environments of subglacial lakes and oceans, collecting data and samples without the risk of contaminating these pristine ecosystems. Missions like NASA's Valkyrie volcanoes, lakes, and environmental robotics for under-ice exploration and IceFin, developed by Georgia Tech, are paving the way for future explorations. These robots are equipped with sophisticated sensors, cameras, and sampling tools, allowing scientists to map the lake beds, analyze water chemistry, and even identify and collect microbial life. The data they gather will provide unprecedented insights into the physical and biological processes at play in these extreme environments. Beyond robotic exploration, advanced sampling techniques are continually being refined. New methods for drilling ice cores are being developed to minimize contamination and maximize the preservation of ancient biological material. Techniques like laser-based ice core sampling allow for incredibly precise analysis of individual layers, revealing minute details about past climates and the microbial communities that existed within them. These innovations are crucial for unlocking the full potential of ice cores as archives of Earth's history and as sources of novel microorganisms. The implications of studying life under ice extend far beyond our own planet, reaching into the realm of astrobiology, the search for life beyond Earth. The icy moons of our solar system, particularly Jupiter's Europa and Saturn's Enceladus, are considered prime candidates for harboring extraterrestrial life. Both moons are believed to possess vast subsurface oceans of liquid water, shielded from the harsh radiation of space by thick icy shells. The conditions within these oceans, cold, dark, and potentially rich in chemical energy, bear striking similarities to Earth's subglacial lakes. By studying the extremophiles and unique ecosystems found beneath Earth's ice, scientists are gaining invaluable insights into the types of life that could exist on these distant icy worlds. The metabolic pathways of chemosynthetic bacteria in subglacial lakes, for instance, provide a terrestrial analog for how life might thrive in the absence of sunlight on Europa. The resilience of tardigrades, capable of surviving extreme conditions, offers a glimpse into the potential hardiness of extraterrestrial organisms. The robotic submarines and sampling techniques developed for Earth's subglacial environments are directly applicable to future missions to Europa and Enceladus, providing the tools and methodologies necessary to explore these alien oceans. The search for life on icy moons is not just about finding extraterrestrial organisms. It is also about understanding the fundamental requirements for life itself. If life can arise and persist in the extreme conditions found beneath Earth's ice, and if similar conditions exist on other celestial bodies, then the universe may be teeming with life in forms we are only just beginning to imagine. The study of Earth's hidden icy worlds is therefore a crucial step in humanity's grand quest to answer one of the most profound questions: are we alone? As we continue to explore these frozen frontiers, we are constantly reminded of the incredible resilience and diversity of life. The ecosystems hidden beneath the ice challenge our preconceived notions of habitability and force us to expand our definition of what it means to be alive. They are a testament to life's ability to adapt, to innovate, and to flourish even in the harshest of conditions. So, the next time you look at a vast expanse of ice, remember the vibrant, unseen world thriving beneath its surface. Remember the microscopic marvels, the hidden lakes, and the ancient secrets waiting to be uncovered. And remember that the quest to understand life under ice is not just a scientific endeavor. It is a journey into the very heart of what makes our planet, and perhaps the universe, so extraordinarily alive. It encourages us to rethink our perception of life and appreciate the incredible resilience and diversity found even in the harshest places on Earth.